Today's lesson is Lesson 3-5, Reteaching. The learning goal for this lesson is to write two expressions that mean the same thing using the distributive property. And we're going to go through a couple different ways that you can do this. So the first thing we're going to do here is look at a word problem. Hector's rock collection is in 7 cases. Each case holds 28 rocks. How many rocks are in Hector's collection? Use the distributive property to find your answer. So the multiplication problem we're trying to solve here is 7 times 28. Because Hector has 7 cases, and each of those cases has 28 rocks in it. But I don't know about you, but I do not know 7 times 28 off the top of my head, so I'm going to break 28 into a number that's easier to multiply by 7 mentally. So I'm going to break 28 into 20 plus 8. Notice how the value of the numbers in my parentheses, 20 plus 8, is still equal to the factor in my problem. We're now going to distribute out that 7 to each of those numbers in the parentheses. So we're first going to do 7 times 20. I'm going to write it right down here. Then we're going to add the product of 7 times 8. These are going to give me my partial products. They're going to help me along the way to find my final product. So when we go to 7 times 20, we know that we can just multiply 7 times 2, which is 14, and add a 0 on the end. Then we're going to add our product of 7 times 8, which is 56. When we add these two numbers together, we're going to get our final product. So 6 plus 0 in our ones place, 5 plus 4 in our tens place, and 1 plus nothing in our hundreds place. So our final product here is going to be 196 rocks. We're going to test this, we're going to try it out a different way. Another way we can do this is to do subtraction. So instead of doing, when we are looking at 28, instead of doing 20 plus 8, we're going to try doing 30 minus 2. So same thing here, we're going to distribute our 7 to our 30. So 7 times 30. The only difference is now we're going to subtract the product of 7 times 2. Okay? So we know once again that we do 7 times 3 and get 21. And our fancy little trick where we can just add our 0 on the end. Then we're going to subtract the partial product of 7 times 2, which is 14. When we do this subtraction, we also get 196 rocks. So far we're pretty sure that we have the right answer, but I'm going to show you, just in case you don't feel comfortable with the distributive property, the last way that we can check our answer. This is something you probably recognize from probably third grade, maybe 4th grade, is the standard algorithm, which we all know is a fancy way of saying the normal multiplication problem. So this is the last way that we're going to check ourselves, just to make sure that we're on the right track. So the first thing we're going to do is 7 times 8, which we know is 56. Put our 6 down there. Carry our 5 over. 7 times 2 now is 14, but we need to add that 5 that we carried over. So when we do 14 plus 5, we get 19. Our final product here is 196. Well, what do you know? That's the same as when we did the distributive property, only we didn't have to work it out quite that hard. So now let's do some practice problems together. The first problem that we're going to start with is number 1 on your reteaching worksheet. We're going to do this one together to make sure you feel really comfortable. So we have the product, or the problem, 3 times 42. Okay, so we're going to break apart 42 to see if we can figure out a little bit easier way to multiply it. So I would do 3 times 40 plus 2. But like we talked about earlier, you could also use subtraction here where you do 3 times, 50 minus 8. That makes it a little bit trickier, but that works as well. So we're going to do the same thing no matter which strategy you choose to use. We're going to distribute the 3. So we have 3 times 40. Then we need to distribute to our other number in our parentheses, which is 2. So we have 3 times 2. So let's find our partial product. Well, I know that 3 times 4 is 12, and then I can add my 0 on the end, plus 3 times 2, which is 6. So when I add these two together, I get 126. Let's see if I get the same thing doing subtraction. When I distribute my 3 out to my 50, I'm going to get 3 times 50. Remember, we're subtracting here. Then 3 times 8. Well, 3 times 5 is 15. And when I add my 0, I get 150. Then we're going to subtract 24. And what do you know? We get 126 as well. So I'm pretty sure that I've got the right answer here. Let's take a look at number 2. Number 2 is 39 times 5. Now in problems like these, I highly recommend using the commutative property and flipping this to be 5 times 39. It's kind of easier to think about it this way. So I'm going to break apart my 39 into two numbers that are easier for me to multiply mentally. So I'm going to do 30 plus 9. When I distribute my 5 out to my 30, I'm going to get 5 times 30 plus 5 times 9. 5 times 3 I know is 15. I add my 0 on the end, plus 5 times 9, which I know is 45. Then I'm going to add these two partial products together and get the final product of 195. This time let's use the standard algorithm to see if our answer is correct. 9 times 5 is 45. Carry my 4 over, put my 5 down in the ones place. 3 times 5 is 15, but I can't forget that 4 up there, so I'm going to do 15 plus 4, which equals 195. Because I got the same answer using both strategies, I know that I must be correct. So let's take a look at one of the problems at the bottom of the page because they seem to be a little bit trickier. So let's take a look at number 9. Here we have the problem 4 times 62 equals 4 times n, which is my unknown number. It's the one I'm trying to figure out what it is, plus 4 times 2. So to solve this, I'm just going to start out with my first little multiplication problem right here, and I'm going to figure out what I would do if I was just solving this problem using the distributive property. So I'm going to have my 4 times, and I'm going to break my 62 into a number that would be easier to mentally multiply. There's a tongue twister for you. I think I'm going to break 62 into 60 plus 2. So then when I use the distributive property, I know I've got to take my 4 times 60 and then distribute my 4 to my 2 as well. So I have 4 times 2. I'm noticing that this problem up here is looking an awful lot like this problem down here. And I know that these two problems need to be equal to each other. So whenever I solve them and answer all of the different parts or figure out all of the different parts, that they need to be equal to each other. So if I look down the line, looking from left to right on both of these, I see that I have two sets of parentheses on both sides. Okay? And I have one that says 4 times 60, and I have one that says 4 times n. Well, those don't match. But I have the second one that says 4 times 2 over here on the left, and one over here that says 4 times 2 on the right. So those two are equal. We need to figure out what needs to happen to this parenthesis, this n, so that it is equal to 4 times 60. Well, I know my 4 times part is the same, so I know that my times needs to be equal to the same number. So my 60 here is equal to n. So in this problem, my answer is going to be n equals 60.